get some stuck with some knowledge. Okay, now we will elaborate whatever we have taken in last meeting, and then we'll solve the numericals. And today I request you that everybody should be with steam tables, okay, and calculator, because today we are going to solve some numericals. Okay, then who will review whatever we have taken in last lecture? Anybody of you? Hmm. Somebody at own? Somebody will come at own. Okay. So Kunal,
Yes, sir.
ah, can you
Uh,
review whatever we have taken last lecture?
okay, sir.
Hmm.
First is isentropic efficiency of turbine.
Okay.
It is defined as actual work developed by turbine to theoretical work developed by turbine.
Okay. Good. Hmm.
Then isentropic efficiency of pump. It is
Okay.
ratio of theoretical work required to actual work required.
Okay.
Then uh, actual
Hmm.
Rankine cycle efficiency can be
Okay.
calculated as uh, H1 minus H4 dash minus H2 dash minus H3 upon H1 minus H4 dash. Then effect of different operating condition on ranking cycle efficiency.
Okay. Hmm. One by one we can tell effect. So
सर ती लिहायचं राहिलं लास्ट तुम्ही पाठवतो म्हणला होता सेंड केलं.
okay. Okay. हाँ. ठीक है. ठीक है. But we are not taken. But at least some remember. Can you remember some
Yes,
something?
sir. Effect of mean or average temperature of heat addition.
Good. Huh?
Then effect of pressure.
Okay.
And,
Okay. Huh?
yes, sir.
Okay. So last lecture I think we have covered whatever Kunal told, it is correct, very much correct. So we have taken the what is efficiency in what is the isentropic efficiency of pump we have defined. Okay. Previous to previous lecture we have completed that. And I think isentropic efficiency of turbine we have defined. Then afterwards we have completed the actual Rankine cycle, okay, on which parameters the Rankine cycle depends, okay. And then afterwards effect of different operating parameters on Rankine cycle efficiency. For example, effect of mean temperature of heat addition, that is TM we have taken, and another is their heat rejection temperature. So efficiency of Rankine cycle is depends on here both, okay, and it is directly proportional to mean temperature of heat addition, okay, and it will inversely proportional to here heat rejection temperature. So if average temperature of heat addition increases, okay, then definitely efficiency of Rankine cycle will goes on increasing, and if the heat rejection temperature goes on decreasing, Rankine cycle efficiency also goes on increasing. So directly here one is inversely proportional and one is directly proportional. Then we have seen that the Rankine cycle polygon, so if I will take the help for, okay, so Rankine cycle polygon. Okay, so effect of Rankine cycle polygon, we know that 1 2 3 4, that is our Rankine cycle. 1 2 3 4 1 is our Rankine cycle polygon, okay, and If the area of that Rankine cycle polygon increases, then work done obtained from cycle increases. And as work done is directly proportional to efficiency, we say that area increases, work done increases, and due to that, efficiency of Rankine cycle will also increase. Okay, so if boiler pressure increases, area of cycle that Rankine cycle goes on increasing, and due to that, what will happen? Here efficiency will definitely increase. So first is we have taken effect of average temperature or mean temperature of heat addition. We got the equation that eta Rankine is equal to 1 minus T2 upon Tm. Okay, therefore if should be T2 should be as minimum as possible to have greater efficiency, and Tm should be as maximum as possible. Okay, so therefore these two is temperatures, Rankine cycle efficiency mainly depends. Then afterwards boiler pressure. Area under TS diagram gives heat supplied, so heat rejected and heat supplied we are getting the information. Okay. Then afterwards we know that if the here, so as boiler pressure increased by keeping all the other conditions constant, okay, fixed. If boiler pressure increased, then definitely what will happen? Here, the area of that Rankine cycle polygon goes on increasing, and due to that, your work done goes on increasing, and due to that, what will happen? Efficiency of Rankine cycle will be increasing. So boiler pressure is directly proportional to your Rankine cycle efficiency. As this much hatched area is there, visible na everybody? Hello,
Not visible, sir.
No, sir.
not we are. Why not? Okay, okay, okay. Okay. Is it visible now? Huh?
Yes, sir.
So okay. So we have uh, Rankine cycle efficiency is here 1 minus T2 upon Tm. Okay, as T2 is goes on decreasing, okay, efficiency will go on increasing. At the same time, if Tm will increase, mean temperature of heat addition will increase, efficiency will also increase. So Rankine cycle efficiency depends on T2 heat reduction temperature and Tm mean temperature of heat addition. Okay, so if Tm is greater, efficiency will be more, T2 will be less, efficiency will be more. So Rankine is directly proportional to Tm. Eta Rankine is inversely proportional to T2. T2 is heat rejection temperature. Then boiler pressure. So another is there that here boiler pressure. So boiler pressure area under TR diagram is showing that this is a Rankine cycle polygon 1, 2, 3, 4. Okay, 1. Okay, so if keeping all other conditions constant, if we increase the boiler pressure, so point number 4 will shift to 4 dash in the diagram, then 4 dash to this is a sensible heat, then this will be latent heat, 4 dash to 1 dash, that will be the heat supplied in boiler. Afterwards from 1 dash, here there will be heat isentropic expansion in steam turbine, and point number 2 will be shift also to 2 dash. But this much hatched area work done, we are getting more from the Rankine cycle. Okay, and due to that, what we say, if boiler pressure increases, area of Rankine cycle polygon goes on increases, and at the same time here efficiency will also increase as work done goes on increasing. So boiler pressure is directly proportional to Rankine cycle efficiency, therefore we say that. Okay, then next is rank condenser pressure. Ah, what in? So condenser pressure is what? Keeping boiler pressure constant. If condenser pressure decreases, again Rankine cycle polygon goes on increasing area, and then definitely as Rankine cycle polygon is increased, net work obtained from cycle goes on increased. How more sir? 3:15. My lecture is at ending at 3. So I will only 5 minutes. 5 minutes. Okay, so 1 dash, 2 dash, 3 dash, 4 dash, 1. So dash. Another cycle is there. Its cycle Rankine cycle area is goes on increasing, and as area increased, Rankine here work done increased, and efficiency will also increase. So eta Rankine is inversely proportional to condenser pressure. Then we know that dry inspection of wet steam. If dry inspection of wet steam is goes on increasing, 1 to 2, 1 dash to 2 dash means here it is less. Here it is going to vapor line, nearer to the vapor line. This is liquid line, this is vapor line. If area is goes this we are coming nearer to the vapor line. So dry inspection goes on increasing. As we increase dry inspection, area of polygon goes on increasing, and therefore as wet steam dry inspection goes on increases, efficiency of cycle also increases, and obviously superheating the steam. So wet steam, less power, less work we will get, less efficiency. Dry and saturated steam, medium efficiency, and superheated steam, maximum efficiency. So that way I think we have completed. Then afterwards we have defined the 3 performance parameters required for our numericals. One is relative efficiency. So who will define relative efficiency, or it is on the screen. Relative efficiency defined as the ratio of actual Rankine cycle efficiency divided by theoretical Rankine cycle efficiency, or eta relative is equal to eta actual divided by eta theoretical. Then next is work ratio. Work ratio is defined as ratio of net work obtained from cycle W net to the turbine work. So that ratio is called as what? Work ratio. Net work divided by turbine work. Okay. So means net work is nothing but W turbine, steam turbine minus W pump divided by W steam turbine. With the help of that equation, one can calculate the work ratio. And work ratio value is nearly equal to, who will tell? Because pump work is negligible. So anybody of you, work ratio value on that day I have told you, we have revised also.
1, sir, near about
1, so
1.
0.98, no, 0.99 or near to 1, because pump work is very less as compared to turbine work. Okay, if pump is turbine is developing 100 kilojoule of work, pump require only 1 kilojoule. Therefore this work ratio will come 1 here 100 minus 1 divided by 100. So 99 minus 100, it will be 0.99. So work ratio is nearly always nearly equal to 1. And lastly, we have defined on that day is a specific steam consumption. What is that specific steam consumption? It is the amount of steam required in kg per hour to generate one electrical unit power. It is 1 kilowatt hour. Here hour is there, 1 kilowatt hour power. Therefore, SS is equal to 3600 divided by W net, or is equal to unit is kg per hour. Specific steam consumption is the amount of steam required to produce one electrical unit power, 1 kilowatt hour power. Okay. Now we have to go for numericals. Okay, shall I? Are you ready for taking numericals? Steam tables are with you. Suppose that calculators may also with you. If yes, we'll proceed. Yes. Kunal is giving yes. Okay, reply yes. Others, please reply. Was oh no problem. Kunal, Pramod, Avlekar, no problem. Okay, so many times one numerical type is always there on the vapor power cycle. Okay, now take one numerical. Is it visible? Numerically visible?
Yes, sir.
Okay. Now take numerical. Write down in your notebook. Steam power plant. Steam power plant working on Rankine cycle. Working on Rankine cycle. Having 1.5 1.5 pressure, sorry, having 1.5 megapascal, having 1.5 megapascal pressure in boiler, having 1.5 megapascal pressure in boiler, pressure in boiler. Okay, steam enters the turbine, steam enters the turbine, steam enters the turbine, is dry and saturated. Steam enters the turbine is dry and saturated, and is expanded in a turbine, and is expanded in a turbine up to a pressure of up to a pressure of 7.5 kilopascal, up to a pressure of 7.5 kilopascal. Find first heater Rankine, second work ratio, third SSC. SSC means SSC means anybody of you? SSC means specific steam consumption. Those are not knowing this term, write down specific steam consumption. And fourth one, heat rejected in condenser. Heat rejected in condenser. And fifth one, heat supplied in boiler. Heat supplied in boiler. Heat supplied in boiler. Heat supplied in boiler. Okay. So steam power plant. Everybody have taken this numerical? If yes, give answer. Reply. Only one reply. Two. Okay, Saurabh Pawar. Okay. Saurabh Pawar, Shineshwar Misal, Kunal. Others not taken. Okay. Okay. Balaji PC. Okay. Now what we'll do? I will go to our PPT. Okay, so that okay. Now this numerical is given to you. Okay. Now first of all, what we have to do is there we have to plot the Rankine cycle or cycle on TS diagram. First of all, our intention is what to plot the cycle in our TS diagram. So we'll go for TS diagram. Okay. So TS diagram is this. Okay. Is it visible? Diagram is TS.
Yes, sir. Yes, sir.
Okay. So TS diagram. Okay. Now, what is steam supplied to a turbine? So this we know that this is our faint line. We can draw it. This is boiler pressure. What is quality of steam that enters into the turbine? We'll tell
Dry and saturated.
dry and saturated. So we have to define this is our condenser pressure. So where will be our point number one? First we'll start from point number one. Where will be our point number one? We'll tell. Where will be our point number one? This is our critical point. Okay. This is our liquid. This is liquid, pure liquid.
Sir, where pressure line and vapor line are joined.
Where is our location of point number one? I am asking. So point number one is dry saturated. So, but at what pressure steam is there? In which boiler pressure? So, at boiler pressure and where dry saturated is there means point number one will be here. This is our TS diagram. Everybody know for dry and saturated steam. So, point number one will be at the vapor line where the boiler pressure and that vapor line intersect. That will be our point number one. Everybody agree? Okay. If it is wet, it will be in between that liquid line and vapor line. If it is yes, you can write yes fastly. Then afterwards, from 1 to 2, it will be going for isentropic expansion. Therefore, 1 to 2 will be isentropic expansion. Vertical line. Okay. This will be point number 2. And 2 to 3, condenser pressure. It is complete expansion in condenser. Okay. Sorry, complete rejection is there in the condenser. And then point number 3. Okay, and from point number 3, it will be in vertical direction. Okay, this will be point number 4. Okay, so 1, 2, 3, 4. This happens in pump, happens in condenser, happens in boiler. Okay. This diagram first of all we have to know. Okay. Everybody agree with this diagram? It's our first step. Right? Yes, no. Otherwise you ask me doubts. Anybody of having problem? Understood. Okay. Okay. Now here what we do is there. Here boiler pressure is there. So here boiler pressure, how much is there? P boiler. Anybody? Unmute and tell.
1.5 megapascal.
1.5 megapascal. But okay, 1.5 megapascal. Now, but in steam table, in which unit pressures are given?
bar.
Bar. So this megapascal we have to convert it into bar. This megapascal we have to convert it into bar. How to convert? Anybody? It is equal to 1.5. Anybody? Into how many mega means how many pascal? किती? 10 raised to 6 pascal. And at the same time, here 1 bar is equal to how many pascal? I have given that relation. 1 bar is equal to how many pascal? 10 raised to
10 raised to 3.
no. How 1 bar is equal to how many pascal? Kilo means 10 raised to 3. 1 is equal to 10 raised to basic relation है क्यों? 1 bar is equal to 10 raised to
5.
5 pascal, and this will become bar. This will become what? Bar unit conversion. Everybody getting? So 1.5 megapascal we have to write into pascal. Okay, and if it is pascal divided by 10 raised to 5, we will get answer in bar. And then final answer is equal to how much bar is there? Anybody? Idi?
15 bar.
15, 1.5 bar. So first of all, we have to do this. It is bar conversions, Pascal pressures. We have to convert it into bar. And here at boiler, wait right here. So if what is pressure is there? 1.5 bar. एक न्यूमेरिकल समजलं की सगळे न्यूमेरिकल समजणार कारण तीच धरतीचे न्यूमेरिकल सगळे आहेत. Everybody getting? All kind, same kind of numerical they are asking. Only instead of dry and saturated point, sometimes they will superheated steam, sometimes dry and saturated. याच्यापेक्षा वेगळं काय असू शकत नाही न्यूमेरिकल. Okay. Then next condenser pressure. What is condenser pressure? How much is given?
7.5 kilopascal.
7.5 kilopascal. Say 1.5 kilopascal. Again, 7.5 kilopascal means how many pascal? 7.5 conversion bar कसं होणार आहे? Into 10 raised to 3 divided by
10 raised to 5.
10 raised to 5. आणि ह्याच्यात किती राहील मग आता? 3 ला 3 कॅन्सल. 10 raised to 2 minus 2 means what? 0. Anybody?
0.75.
0.075 bar. It contains the pressure. We will write 0.075 bar. Everybody got this conversions? Draw the diagram then. I'll give 2 minutes to you. And the deep diagram is over. Write down completed C. Diagram is over. Write completed C. And diagram and this calculation. Given data. Boiler pressure, condenser pressure, everything. Okay. Now, whatever they asked, it may be eta ranking cycle efficiency they asked. So for all these parameters, what we need? Anybody? हे न्यूमेरिकल जास्त वेळ लागेल कारण हे न्यूमेरिकल आपलं खूप महत्वाचं आहे.
एंथॅल्पी
एंथॅल्पी कुठले कुठले एंथॅल्पी आहे आपल्याला? स्पेसिफिक एंथॅल्पी 1 2 3 4. इटा रँकिन फॉर्म्युला काय आपला इटा रँकिनचा? व्हॉट इज फॉर्म्युला फॉर इटा रँकिन? हीट सप्लाइड. काय असते हीट सप्लाइड? H1 मायनस
H2
H4. H4 मायनस H4. ओके. Minus heat rejected H2 minus H3 divided by heat supplied H1 minus H4. This formula everybody should remember. It should be on your tip of your tongue. Okay. Now tell me H1, H2, H3, H4 where to find out. Then with the help of steam tables are with you. We know 15 bar what is condition of 1. At point 2 what is pressure, how we can calculate the enthalpy at point number 2, how we can calculate enthalpy at point number 3, how we can calculate the enthalpy at point number 4. So these 4 points enthalpy we have to calculate. If it get calculated, other things are very 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 simple. So only we have to put in the formulae and we have to get the answers. Now depending on the condition. Now here what is H1? कोण सांगते H1 म्हणजे काय असू शकतं? बघू तुमचं स्टीम टेबलचं नॉलेज. आय वॉन्ट इंटरॅक्शन स्टेशन. H1 is equal to
Hg at 15 bar.
Hg at
15 bar.
15 bar. Correct. Because it is what? Point number 1 is what? Dry and saturated steam, and pressure corresponding to it is 15 bar. So H1 is equal to Hg at 15 bar. Who agree? All agree with this? Hope that everybody is having steam table. Okay. Okay. Shaneshwar Misra, no problem. Okay. Others, please reply so that I will get confident that you are understanding. H1 is equal to Hg at 15 bar. Now, this is dry saturated steam. Pressure we know, and Hg we have to find out. So, which steam table we have to refer? Table number
2.
Table number 2. Table number, by referring table number 2, H1 is equal to, now Hg of table number 2 for 15 bar. Whether you can draw or I have to go for
278.9.
Okay, so all agree that I should take values from you only, or I have to show the values? 2
7 8 9
okay. 8 9 okay.
0.9.
0.9. Unit is always kilojoule per kg. Okay. Anybody want that Gauri sir should show you steam table? Shaneshwar Misra also got. Shubham. Okay. Okay. So everybody agree that I should use this value directly, or I have to show this value how it is coming from steam table, because now everybody know how to read the steam table. If anybody has still problem, I am ready to show you the value how it is extracted from steam table. Shall we proceed, or shall I show steam table? तुम्ही सांगायचंय मला, म्हणजे ओके ज्याला प्रॉब्लेम आहे त्यांनी विचारा. प्रॉब्लेम आहे? Shall we proceed? Right reply. Yes, sir. Continue. Go ahead that way. Okay, Kunal. Okay. Sineshwar Mishra, no problem. Yes. Okay. So shall we continue? Okay. Okay, good. Then H2. Write down this. With me, write down. Ranking is equal to H1 minus H4 minus H2. Theta ranking is equal to H1 minus H4 minus H2 minus H3 divided by H1 minus H4. Then H1 is equal to Hg at 15 bar. Table number 2 we have to refer. H1 is equal to 2789.9 kilojoule per kg. Okay. Then point number 2 I'll write here. Point number 2. Where it is the point number 2? Point number 2 is in wet region.
Wait.
Am I right? Point number 2 is in wet region. 2 is in point 2 only. I will write here. Point, write down with me. Point 2 is in wet region. Wet region. Point 2 is in wet region. Then how to calculate enthalpy of wet steam or wet region property? Anybody know? H2 is equal to,
H4 plus
therefore
X into HFG
H2 H2 is equal to HF
plus X
plus
into HFG.
X. It means shall I write X2? Point number 2 data special will be HFG. Very good. And this HF and HFG I have to record at which pressure? Mention in
0.0
okay.
0.075
0.075 bar. 0.075 bar. Now table number again, same table. Table number 2 we have to refer. Okay. And we have to find out this H2. Therefore H2 is coming as, who will tell? H2 is equal to, who will tell? HF at 0.075 bar. Available, or you can mention in your message box value of HF or that equation only. HF2 is equal to HF at 0.075 bar. Shall I open my steam table?
Sir, 168.65.
One Kunal's answer 168. Direct it is available or you have made mean average?
Average, sir. By average.
Okay. 0.7 and 0.8. 0.08, correct na? 0.07 and
Yes, sir.
0.08. That values are available and from that you have taken average. H2 is equal to 168.65.
65.
Okay, plus X2 we are not knowing as it is. X2 into, what is the HFG value? HFG value at which pressure again? 0.075 bar. HFG value. HFG, who will tell?
2406.
2, 4, 0, 6, okay.
0.2.
Point something. 0.2. 0.2. Get this, give this equation number as equation number 1, something. Write this, and if it is right completed, then tell me the value. Okay, so h2 is equal to 168.6665 plus x2 into 2406.2. Everybody understand? H1 H2, but we are not knowing x2, we are not knowing x2. And yes, who will tell me hint how to calculate h2, x2? Shall I proceed to next page?
Yes,
Shall
sir.
I proceed? Okay. Then to calculate x2, write down here. What do I have to use? Anybody? X2 determination of x2 is right here. Determination of x2.
We have to calculate this one.
Huh?
We have to calculate
We have to
this one.
calculate x2. S1. But for that, what do I have to go for? Here, S1 is equal to, write
Yes,
equation.
two.
S1 is equal to S2. Why? Reason also I have to give. What is that reason?
Process is isentropic.
What is 1 to 2 process? Isentropic process. Isentropic. Isentropic process. Then, what is S1? We will tell value of S1. S1 is equal to, we will tell
SF plus F into SF.
S1 is equal to, see the point
S
S1. What is the point number 1 S1? Where it is S1 point? I am highlighting. Point number 1. Where it is point number 1? Anybody can guess? What will be S1? Like guess H. What were written? S1
SF
is H1 is Hg at 15 bar. Similarly, S1 is equal to
SF plus
SG at 15 bar. It is dry and saturated condition. Point number 1 condition is what? Dry and saturated. Therefore, S1 is equal to Sg at किती bar? 15 bar. You already understand? What is the value? We will tell value now. Table number again same. Table number 2. Table number 2, but instead of Hg we have to see the value of Sg. Anybody can tell?
6.441.
6.441 kilojoule per kg Kelvin. Okay, 6.441 kilojoule per kg Kelvin. S1 is equal to Sg at 15 bar. Then what is value of S2? Point number 2, again see diagram. Point number 2 is again a wet region. Therefore, what will be the value? S2 is equal to, anybody?
6 SF plus
Okay, good. SF plus
X2 into SFG.
X2 X2 into SFG. Okay, but SF and SFG we have to record at which pressure? Anybody?
0.075.
0. Point. Okay. And now we will tell values. Therefore, S2 is coming out. I will okay. I will use one more page. Therefore, SF at 0.075 bar. Again, table number 2. Somebody can tell. SF at 0.075 bar.
0.576.
0.576 plus x2 into SFG value at 0.075 bar. Somebody.
7.6775.
7.6
775.
7 7. ठीक है, this much is accurate. Good. Okay, but we know that S1 is equal to S2, so this should be equal. Therefore, what we can write next equation? Write with me. Yeah, everybody should write this numerical. Very important. 6.441 S1 is equal to 0.576 plus x2 into 7.677. Therefore, x2 is equal to
0.76.
point 2 digits only. You consider calculator adjust for 2 digits. 0.76. Everybody understand? इथपर्यंत अंडरस्टँड काय प्रॉब्लेम कुणाला? ह्याचे न्यूमेरिकल आधी आपण सोडवले होते थोडे बॉईल चॅप्टर नंबर 2 ला. शुभम गांडोळे 0.77. चेक दॅट वेदर इट इज 0.77 और 0.76. 2 digit पर्यंत आपण कन्सिडर करायचंय. ओके, 0.76 or 0.77, no problem. Shubham, you are also correct. Okay, now what we have to go for? H2 we have to calculate. Then what is H2 equation we got? Equation number 1. We are having equation number 1. Shall I go to that page or somebody can help me to tell that equation? Kunal, already you are online.
Yes, sir. H2 is
Tell
equal
that
to
equation or I have to go to next.
H2
Tell.
168.65.
168.15.
65.
65. Okay. Plus x2 into किती HFG
2406.
2406.2, and this now you put x2 is equal to this value, and what is the equation where what value we are getting h2? So Shubham Gandole got value 19. Shall I write? Shanesh also same 9. So 1997. Correct? Point 3 I will write, or 0.36. Correct or not? Okay, promote everybody. Everybody agree with this answer? H1 is equal to H2. Okay. Then what will be H3 value? What will be H3 value?
HF.
HF, correct. HF at कुठलं pressure किती?
.075.
Okay, good, very good. So HF H3 is equal to what we can write now. H3 is equal to HF. मग जसं आपण H ची म्हणलं तसं HF at 0.070 0.075 bar. Okay, and this value is equal to, already we are using this value in equation number 2, HF at 0.075 bar. So this value only. For that value, anybody? 168.65 kilojoule per kg. Kilojoule per kg. Everybody got now how to calculate H1 value, H2 value, and H3 value. Shall I proceed? H1, H2, H3 value. If everybody calculated, then we'll proceed. Kunal, yes. Okay. Kunal, Shaneshwar, not Shaneshwar. Okay. Okay. So okay. Good. 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 Then value of H4. For value of H4, this point now, okay, this point is not in our stream table. So this is only stream table data is available from this liquid line to vapor line and some separated point region. But point number four is coming in subcooled region. Right hand to left liquid line means subcooled region. And here there is no information in stream table for the subcooled. Then for that, what we are doing, we are having one equation. What is that equation? W pump we can know. So what is that equation there? H4 is equal, H W pump is equal to, right? Everybody written W pump is equal to H4 minus H3. H4 minus H3. Okay, and therefore H4 is equal to काय value? Anybody? H4 is equal to इकडे गेले H3 तर काय
W pump plus H3.
W pump plus H3 किंवा H3 plus W pump. Okay, this underline this formula. H4 is equal to what? H3 plus W pump, because subcooled values, subcooled points data or subcooled condition data is not available in stream table. It is available from liquid line to vapor line, wet region or separator region. For wet subcooled region, that data is not available. So H4 is equal to H3 plus W pump. Okay, but then W pump, how to calculate? It is now I will give the formula. This formula everybody should know. आता मी तुम्हाला सोपा करून दाखवतो इथं. W pump is equal to okay, W pump is equal to 100 no, sorry, not 100, 0.1. Point 1 into boiler pressure in bar, right on PB PB in bar minus condenser PC in bar. This formula how you will come, you will tell, I will tell afterwards. Because now I think we are getting this here. It need 15 20 5 to 10 minutes. Okay. So 0.1 into, actually it is VDP work and it is coming. So I will tell, and unit conversions are there. But remember that W pump is equal to 0.1 into boiler PB in bar minus PC in bar. Everybody understood? PB in bar minus PC in bar, and therefore W pump is coming as खूप कमी वर कसं लागतं पंपला 0.1. किती आहे बॉयलर प्रेशर इन बार विल टेल
15.
सो बॉयलर प्रेशर बघ फक्त हे बार मला युनिट लक्षात ठेवावं लागेल बरं तुम्हाला, कारण युनिट कन्वर्जन करून आणले आपण ते. 15 मायनस 0 कंडेन्सर प्रेशर किती आहे
0.07.
0.075. This formula you able to remember, square bracket formula, and this value is coming as, this is in kilojoule per kg. Yeah? This value we are getting in answer, we are getting in kilojoule per kg. We'll tell value 0.1 into 15 minus 0.075. Okay.
1.4925.
1.449. Okay. 2 digits. Okay. Let it be kilojoule per kg. Everybody understand this W pump? How to calculate? Okay. For that formula, we have to use is what? One Shubham Shingan 1.4925. Good. No problem. Shanesh also getting same answer. So 1.49 kilojoule per kg. Then what will be H4 value?
170.
170. Shall I write directly? WH3 plus W pump 170.
0.1425.
0.14 I will write. Okay. Kilojoule per kg. Okay. Everybody understand? Frankly, you tell me whether you understand. Anybody has problem related to finding out the value of H1, H2, H3, H4? Same kind of numericals we have to solve every time. So same procedure we are going to repeat. Anybody having problem, mention NN so that I will proceed further. H1, H2, H4 vehicle. Now our steam table is not required. Only for up to this we needed steam table. No problem. Good. Then now we can write our EP, since eta Rankine we can find out. Put the values in our equation. Eta Rankine is equal to, I will write for simplicity, eta Rankine. Eta Rankine is equal to, and formula. Atalla. Hello. Eta Rankine is equal to, what is formula? H1 minus H4 किंवा H दोन्ही पण W पण दोन्ही वापरू शकता तुम्ही मॅथमॅटिकली रिअरेंज करून. डिवाइड बाय H2 minus H3 divided by it's applied H1 minus H4. Now here I will not solve this here in detail. So everybody know values of H1 is what value? What is value of H4, H2, H3, H1, H4? Put the values and tell me the answer. Write answer for a better way, and in bracket point something you are getting. 30
Sir,
point
30.19.
30.19 percentage ना, it is value in
Yes, sir.
percentage. 13.40. and remember that ते कुठे वाक्य लिहून ठेवा मनामध्ये, ह्याच्यामध्ये पण राहा तुमच्या मेमरीमध्ये आणि वहीमध्ये पण. रँकिंग सायकल इफिशियन्सी जनरली व्हेरीज इन बिटवीन 30 to 40%. 30%च्या जवळ असते. लिहून ठेवा, इफिशियन्सी व्हेरीज फ्रॉम 30 to 40%. 50% वगैरे जर आले तर आपले चुकले पण आहेत कुठं तर. ओके, किंवा आन्सर चेक करायचं पण एकदा. इट शुड बी व्हॅल्यू शुड बी इन बिटवीन, कोण सांगता एकदा रिपीट. रँकिंग सायकल इफिशियन्सी
30
व्हेरीज
to
इन बिटवीन 30 to 40%. एमसीबीला पण कधी कधी विचारतात बरं का. राईट, रिमेंबर वहीमध्ये पण लिहा. ओके, shall I proceed next point? This is our first answer they was. Ranking cycle efficiency is coming as 30.19%. Okay. Now next, what parameter they asked? Next, मला 3 स्लाइड जावं लागते. कोण सांगते, मदत करते? नेक्स्ट पॅरामीटर व्हॉट दे आस्क्ड?
work ratio.
वर्क रेशो. ओके, देन वर्क रेशो. What is work ratio? For its formula work ratio WR. या फॉर्म्युला त्याला W net divided by
Work
W
developed by the
steam turbine ST, or is equal to काय असतं W net? WST minus W pump divided by WST. ओके, आता W पंप काढलाय आपण, किती आहे आपला? 1.49. WST आपल्याला काढायचा आहे. विल टेल W पंप कुठे आहे? स्टीम टर्बाईन आपला. हिअर स्टीम टर्बाईन इज इन हिअर 1 to 2 प्रोसेस. म्हणजे त्याचं जेव्हा स्टीम टर्बाईनमध्ये स्टीम आत जाते तेव्हा त्याची एन्थॅल्पी असते H1. जेव्हा बाहेर पडते आणि कंडेन्सरला जायला चालू करते तेव्हा त्याची एन्थॅल्पी असते H2. म्हणजे कमी कुठली आहे? H2. जास्त कुठली आहे? H1. बाकीची गेली कुठं? स्टीम टर्बाईन इज डेव्हलपिंग वर्क दॅट इज WST. therefore it the value is given by anybody. आपण शिकवलंय मी तुम्हाला, सांगितले फॉर्म्युला असो. एनीबडी? काय WST ची व्हॅल्यू काय असणार? H1 आणि H2 मध्ये माहित पाहिजे. हाऊ मेनी टाइम्स आय हॅव H1 एन्थाल्पी ड्रॉप इन स्टीम टर्बाईन. H1 मायनस मायनस H2.
H2.
बरं करा, H2 करेक्ट. H1 मायनस H2. आणि किती व्हॅल्यू मग आता पुटअप करा. H1 and H2. H1 we know, H2 we know, and what is value is coming? W steam turbine. H1 मायनस H2 किती येते टर्बाईन वर्क, पंपचं वर्क माहिती आहे आपल्याला. दिस वी कॅन यूज हिअर. Suhas got 792. Shall I write Suhas? Correct. 792.54. Unit देत चला. Unit is very important. Kilojoule per kg. ओके. शुभम गांडुळेने पुढचं काढले उत्तर. गुड. पण टर्बाईन वर्क करेक्ट 792.54 करेक्ट. सुहास अँड सेन्सर दे गॉट सेम. ओके. देन वर्क रेशो. काय ते वर्क रेशो आपला? किती? W 792.54 मायनस किती?
सर 99%, 99.81.
1.49. गुड. काय नाही, फक्त पंपचं वर्क खूप कमी आहे बघा. टर्बाईन आपला डेव्हलप किती करतोय? 792.54 म्हणजे 800च्या आसपास तयार करून सुद्धा पंप फक्त 1.5 किलो एवढी एनर्जी लागते. तर किती लागतोय? पॉईंट किती? 9999 और 999. व्हेरी म्हणजे वर्क रेशो नियरली इक्वल टू 1 असतोच. ओके. पुन्हा काय विचारलं त्यांनी? नेक्स्ट पॅरामीटर दे आस्कड.
SSC.
SSC. व्हॉट इज SSC फॉर्म्युला? कोण सांगते फॉर्म्युला? फॉर्म्युला टिप ऑफ टंग पाहिजे. 3600 डिवाइड बाय W नेट. बरोबर आहे का? अँड इज इक्वल टू काय येणार? W नेट पुन्हा 3600 डिवाइड बाय W नेट म्हणजे काय? WST पुन्हा असं होत आला ST मायनस W पंप. किती येईल मग SSC? स्पेसिफिक स्टीम कन्झम्पशन. विल टेल. WST माहित आहे, W पंप माहित आहे, किलोजूल पर के. सगळे आन्सर आपले किलोजूल पर केजी आहेत. WST W पंप, कारण आपल्या एन्थॅल्पी सगळ्या किलोजूल मध्ये आहे आणि एंट्रॉपी किलोजूल पर केजी केल्विन. 4.55.
The network done is 79.791.
ठीक आहे. ओके. हे कॉन्स्टंट लिहू 791.
1.04.
ठीक आहे. बट आन्सर इज कमिंग एज 4.55 किलोवॅट kg पर किलोवॅट आवर. म्हणजे 1 युनिट तयार करायला आपल्या स्टीम किती लागते ह्या कंडिशनची? 4.55 kg. 4.55 kg पर किलोवॅट आवर. ओके. अजून काय विचार त्यांनी? नेक्स्ट पॅरामीटर
Heat rejected in condenser.
HR हीट रिजेक्टेड इन कंडेन्सर. ओके. कुठं कंडेन्सर मध्ये असते HR किती येणार? किंवा QR म्हणून तिला आपण काय सिम्बॉल करू? QR इज इक्वल टू काय येते? H2 कुठं कंडेन्सर हीट रिजेक्ट कुठं होते? H2 मायनस H3 किती येते? कॅल्क्युलेट. H2 minus H3 1828 8.71. Shineshwar got that answer. Joule per kg. Okay. Then anything they asked? Anything more they asked?
Heat supplied.
Heat supplied in boiler. Okay. QS. काय फॉर्म्युला QS चा? H4 minus H4. काय फॉर्म्युला H4 सांगा. Two 619. .76. Okay. Anything? Any more they asked?
No, sir.
एव्हरीबडी अंडरस्टँड. एक तुम्हाला प्रत्येक वेळ दिला होतं काय ह्यात तुम्हाला समजलं काय अडचण? इफ नो इज देअर पुट इन नो 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 शो दॅट वी कॅन नेक्स्ट टू न्यूमेरिकल विल प्रोसीड. आता हे तुम्ही न्यूमेरिकल सोडवायचे मी फक्त तुम्हाला फक्त हिंट देणार. हिंट ऑलरेडी शुभम शनेश्वर नो प्रॉब्लेम. ओनली शनेश्वर सुहास. ओके. प्रमोद आवलेकर, सोहम ओहरेकर, गुड. शुभम गांडुळे. ओके. शुभम शिंगण also our friend Saurabh, no problem. Okay, so shall we'll go to new numerical. Okay. Okay, so heat is rejected in condenser that already. We'll now check our answers. Okay, हे अशी डायग्राम काढायची पहिल्यांदा न्यूमेरिकल वही सोडवताना कसं काळजी घ्यायची. आन्सर शीट मध्ये 4 टोन व्यवस्थित डायग्राम काढायचे. पहिल्यांदा TS डायग्राम काढायची आपल्याला. ओके. 1.5 मेगापास्कल म्हणजे आपण कन्वर्ट केलं 1.5 इंटू 10⁶ डिवाइड बाय 10⁵ इज इक्वल टू 15 बार आणि 0.075 बार. ओके. H1 इज इक्वल टू Hg ॲट 15 बार 2789.9 किलोजूल पर kg. डिटर्मिनेशन ऑफ H2 पोटॅटो पॉईंट वेट रिजनला म्हणून H2 प्लस HF प्लस X2 HFG ॲट 0.075 बार. तर व्हॅल्यू नाही म्हणून आपण काय केलं ॲव्हरेज काढले तुम्ही पण. इक्वेशन नंबर 1 म्हणलं आपण. डिटर्मिनेशन किंवा कॅल्क्युलेशन ऑफ X2 ॲज एक्सपान्शन इज आयसेंट्रॉपिक. S1 इज इक्वल टू S2. F1 इज इक्वल टू Sg as Sg 6.441. S2 SF प्लस X2 इंटू SFG तुम्ही त्यामुळे काढले आणि X2 आला आपला 0.7639. 0.76. ओके. पुट इन इक्वेशन 1. H2 आला 1997. आपले व्हॅल्यू बरोबर आहेत ना? त्याच्याप्रमाणे आहेत ना? करेक्ट असेल मला वाटते. X2 पर्यंत बरोबर आहे. नियर अबाउट आहेत.
Sir, why is zero?
काय म्हणताय कोणाला?
No, voice is not clear.
ओके. H2 व्हॅल्यूज आर विथ नोटबुक व्हॅल्यूज ना, मॅचिंग ना, व्हॅल्यू मॅच होतात का?
Yes, sir.
ओके
Matching.
ओके. तेच H3 इज इक्वल टू HF ॲट 0.075 बार. H3 इज इक्वल टू पण आपण कॅल्क्युलेट केलं 168.05. W पंपचं इम्पॉर्टंट फॉर्म्युला. ओके. काय केलं आपण पी बॉयलर इन बार मायनस पी कंडेन्सर इन बार इंटू 0.1 0.1 0.1 आणि उत्तराला आपलं 1.49 आणि डब्ल्यू पंप H4 we calculate 170 then ita ranking we got 30.19%. Then WR we are getting work ratio 0.99 correct. It rejected in condenser H2 minus H3 is equal to 1828.71 and 4.5 kg per kilowatt hour. It supplied to 619. And now next numerical. Steam power plant working on ideal Rankine cycle having dry and saturated steam at 2.5 megapascal pressure for the steam turbine. The condenser pressure in the plant is maintained at 0.1 bar. Find Rankine efficiency, work ratio, SSC, heat rejected in condenser and heat supplied. Are you able to solve this at your own? Are you able to solve? Put yes,
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 sir.
yes. Okay. Everybody should put yes. Okay, now you start solving the numerical. Numerical is on getting, everybody is getting numerical, no problem. Visibility, etc. Now till that you solve numerical, till that I will take attendance. Okay, roll number 1.
Yes, sir.
Roll number 1 is present. Okay. Saurabh, okay. Roll number 2.
Present, sir.
Roll number 2 present. Roll number 3.
Present, sir.
Roll number 4. 4 absent. 5. 6. 7. 8. 9. 10. 11 present. 11.
Present.
Was.
Yes, sir.
Getting numerical getting.
Yes, sir.
Okay. 12.
Yes, sir.
Okay. Rahul कुठे असतं राहुल? 12. You are 12 or 13? 13. Rahul Khadke present. 14.
13
13 present.
present,
Okay.
sir. Sir, आवाज येत नाही.
आवाज? मला आवाज येत नाही? येतोय की राहुल? हा. 14. 15. 15. 16. 17.
17 present.
17 present. Okay. 18. 19.
Yes, sir.
ओके 19 अजित गायकवाड. ओके ओके
19
अजित
present, sir.
काय लक्ष आहे की नाही समजतंय का?
Yes, sir.
ओके
Okay.
20.
Present, sir.
ओके प्रसन्ना समजतंय का? ओके 21. 21. 22.
Yes, sir.
सुयोग जाधव काय कधी असताय कधी नसताय समजतंय का?
Yes, sir.
थोडं काय न्यूमेरिकल स्टीम टेबल वगैरे समजलाय? ट्वेंटी थ्री. 24. 25. 26. 27.
Yes, sir.
ओके अविनाश जाधव काय समजतंय का?
Yes, sir.
टीम टेबल वगैरे समजलाय? 28. 29. 30.
Present, sir.
ओके सौरभ शिंदे समजतंय का सगळं? सौरभ
Yes, sir.
टीम टेबल वगैरे समजलं सगळं?
Yes, sir.
ओके 31.
हो, sir.
ओके 31. 32. 33. 34.
Sir.
34. शनेश्वर नो प्रॉब्लेम. शनेश्वर समजते समजते ना शनेश्वर? 34 yes present.
Yes, sir. Understood.
ओके 35.
Yes, sir. 35 present.
शुभम नो प्रॉब्लेम. शुभम समजते?
Yes, sir.
ओके 36. 37.
Present, sir.
ओके सोहम समजते का?
Yes, sir.
ओके 38. 39. 40. 41.
40 present.
40 प्रेझेंट. गौरव समजते का?
हाँ, sir.
40. ओके 41. 42.
Present, sir.
सुजीत समजते का?
Yes, sir.
ओके 42. 43. Everybody note don't left. Words all numerical. 42. 42 present. 43. 44. 45. 46.
Yes, sir.
40. 46.
46.
Present. 46 present. 47. Kedar, are you understanding?
Yes, sir.
Okay. 47. 48. 49. 50. 51. 52. 53.
Yes, sir.
53 present. प्रथमेश समजते?
Yes, sir.
टीम टेबल समजते सगळा?
Yes, yes, sir.
54 न्यूमेरिकल छोड़ हो जाएगा आता
Yes.
54 55 56 57 58 59
Yes, sir. 58 present.
58 present okay कौन है 58
Sir, Pramod.
प्रमोद आवलेकर ओके समझते हैं प्रमोद
Yes, sir. Understand.
न्यूमेरिकल are you solving numerical
Yes, sir. Solving.
okay good 59 Balaji
Yes, sir.
understanding
Yes, sir. Understanding. No
okay
problem.
60 Balaji are you solving numerical
Yes, sir. Solving
okay
now.
good 60 61 62 63 64 65
65 present, sir.
okay Kunal okay sorry
Present, sir.
Kunal okay I should not ask you understanding or not your understanding Kunal
Yes, sir.
okay solving numerical
Yes, sir. Understand.
okay
Yes, sir.
66 67
Yes, sir.
Sainath understanding
Yes, sir.
okay 68 69 don't leave the class 69 69 70 71 2 3 4 5 6 7 78 okay efficiency Kunal got 31.15%. Kunal got a efficiency. Others, please try.
Roll number 47.
Roll number 47. I have taken attendance, no problem. Mark you present 47, na? Okay, 47. Good. Okay. समझते का 2% 2%
Yes. Yes, sir.
असता ना प्रेझेंट प्रत्येक वर्गात प्रत्येक क्लासला
Yes, sir. Present.
ओके अंडरस्टँडिंग ना नो प्रॉब्लेम present you don't put present e only solve numerical now okay so this is our numerical again steam supplied is dry and saturated they are mentioned in this numerical okay therefore we have to draw the ts diagram for the same 1 to 2 a steam turbine process, isentropic expansion, TS diagram, condenser 2 to 3 process, 3 to 4 is in pump, and 4 to 1 is in boiler. Okay, so P boiler is there 2.5 megapascal, 2.5 into 10 to 25 bar. Condenser pressure is coming as 0.1 bar. Already they have mentioned in bar, therefore no conversion. Now P condenser 0.1 bar. Okay, H1 is equal to Hg at 25 bar. So 25 bar Hg value we have to take. It might be coming as 2801.0 kilojoule per kg. Okay, again point number 2 is in weight region. Up to this I think everybody is completed. H2 is equal to HF plus X2 into HFG at 0.1 bar. Okay, so at 0.1 bar, HF is 191.8 plus X2 into 2392.91. Okay, then calculation of X2. S1 is equal to S2, isentropic process. And therefore, S1 is equal to at 25 bar SG. S1 is equal to SG at 25 bar 6.253. Okay, and S2 is coming as weight region SF plus X2 into SFG. SF and SFG are to record at 0.1 bar. So 0.649 plus 7.502, and it will give answer 6.253 is equal to 0.649 plus X2 into 7.502, and 2 digits if we consider, X2 is coming as 0.75. And put that X2 value, put that X2 value in equation 1. Okay, and therefore H2 is coming as H2 is equal to HF plus X2 HFG. Therefore H2 is coming as 197.1979.29 kilojoule per kg, and H3 is equal to HF at 0.1 bar. Already that in equation it is there. HF equation लिहिलं असतं H2 चं, त्यामधला H3 is equal to HF is equal to 191.8. Okay, then pump work H4 is equal to W3 plus H3 plus W pump, and therefore W pump is equal to, we know, boiler pressure in bar minus condenser pressure in bar into 0.1. W pump is coming as 2.49, and H4 is coming as, if you add in H3 in that, 194.29 kilojoule per kg. Then eta ranking, heat supplied H1 minus H4 minus heat rejected H2 minus H3 divided by H1 minus H4, and that will coming as answer is coming as, I think many of you have got that answer good, 32.16. Little bit here and there, no problem, but 31.42, that student answer is there, it is not book answer. Therefore maybe little bit variation depending on how many digits we are considering after. Okay, then Shaneshwar, Kunal, okay, Kunal 31.15. Okay, let it be 1 or 2% here and there, no problem. Work ratio. Okay, work ratio, then W net means H1 minus H2 minus HW pump divided by H1 minus H2, and it is coming as 0.99. Okay, 0.99. So group or promote or this previous numerical. Okay, then SSC W3600 net 4.93, 4.396, 4.4 near about. Okay, it rejected 1787. It supplied to 606. That way, if we know all H1, H2, H3, H4, then we can calculate. Still, I will scroll down this numerical once again. Anybody having problem? Okay, so one more numerical. I will give one from here. I'll put this numerical in our group or otherwise assignment if it is there. This numerical as homework. Huh? This numerical as homework you solve. Okay, good. Kunal, take this numerical as a homework and solve. So I request all of you to consider this numerical as our test. So test number one, test you can test on chapter 4. You can write this numerical, and this numerical you have to write in here, make solve, and you have to make it PDF, scan it, make it JPG or PDF, and send to my email ID. My email ID, everybody know?